So good afternoon, everyone. My name is Ian, and I'm pitching to you today on behalf of Pasture Pro. So this is most of our team. I think somebody's escaped. So the problem that we were asked to consider was how do we basically improve pasture on farmland. And to do this, we considered two kind of areas within the pasture, and that could be inefficient pasture utilization. So this can be things like over or undergrazing, which can lead to poor milk quality and environmental issues. And also there's a drive at the moment to have multi-species forests, so to move away from the grass-only pasture and have a grass-clover mix. And there's governmental push for this as well at the moment, so we're trying to help. So we're looking at this as well as a kind of a pasture issue. So the question we asked is, how can we develop something that can minimize inefficiency and help simplify this transition to multi-species forests for farmers? And the answer we came up with is to look at continuous pasture monitoring. So to do this, we deploy a number of existing sensors on the farm. So for example, we could have mini cameras, which would allow us to identify the sward species. Soil moisture probes, so this can ensure that there's sufficient carrying over nutrients. GPS trackers, so these could be put on the cows to see where they're grazing and is there areas that could be at risk of overgrazing. So we could use things like what pasture-based use, which is grasshopper, to measure things like grass height and grass density. And things like thermometers, just to monitor areas of the farm where there's the highest amount of activity. So this would be, if you weren't using GPS, you could look at areas where the soil was at its warmest. And to deploy these, we're also using techniques that are already existing. So we could look at from the lower budget farms, or where they don't have as much expenditure for these types of things just like soil probes, that we can dot these around the pasture in different areas. GPS collars exist for cows, so we could piggyback off this and put on our cameras so we can see where the cows are grazing and also what their preference is for. At the more higher budgeted farms, you could look at things like the robotic fencing. So again, to deploy the sensors on these to monitor the soil as it's moving around the farm. And again, the best case scenario for the really high budget is to have something like a robotic lawnmower that monitors the farm continuously throughout. So you're not taking representations, you're actually taking measurements at each part of the pasture. So we're not developing the sensors and we're not really developing the techniques for deploying it. So where are we different and what will Pasture Pro consist of? And what we're looking at is to use this information to develop a pasture digital twin. So we can use all the data that we're getting from all these sensors and also things like weather forecasts and weather patterns and feed this in so we can create a digital twin so the farmer can actually have access to his farm or his pasture at all times and be able to see how things are progressing in the farm. We also want to develop algorithms and analytics that allow us to make predictions based on what's actually going on in the farm and to offer suggestions to the farmer. Now we know that our experience doesn't surpass a farmer, so we're giving the farmer the option to accept or reject these changes and allow the algorithm to learn from this and grow season upon season. So we see this as a subscription service where there would be an initial down payment for the sensors and the setting up of the digital twin and continuous payment then for software monitoring and software updates. And the idea is that the algorithm should become more intelligent with each passing year, so it becomes more useful. An example here is of what we would imagine this would look like. It's an iterative model, so they don't necessarily need to spend all the money for the highest quality thing. They can start small and see if it's something that suits them. So you can imagine that with some of the basic sensors, you can just be looking at grass density throughout the farm, throughout the pasture, and then as it goes on, you can see things like it's looking at where the cows are moving, where areas that are over undergrazed, where's the highest soil moisture, and also offer suggestions such as this heavy rain forecast within 48 hours, avoid applying fertilizer, just to help the farmer with their pasture. So as you can imagine, there's an array of benefits with this. So it makes the life for the farmer easier and it can improve profits. But another thing that we're interested in looking at is the fact that this could be future-proof. As new sensors become available, we can feed these into the digital twin model. So if sensors become available for looking at soil nitrates or soil phosphates, we can fit this into digital twin so that it can constantly grow and update. We also see this as having potential alternative revenue streams. So we're looking at this initially from the perspective of a farmer, but it could suit anyone that has any area of grassland. So we'd imagine that maybe hobbyists who are looking to maintain a garden could potentially use the same technology, but would be paying less for this. But the idea would be that we're appealing to a wider range of customers, even though they're paying less, we have a consistent revenue stream. So we're happy to take any questions. So my team is here, so we can take any questions that you